Okay, now we see the equivalent circuit of the solar cell. This is how we draw it. The circuit look like we have a resistance, we name it as RS. Then we have another resistance here, we name it RSH, and we have a diode, and we have a load. Okay, now we name it that this current through the diode, name it ID, and this one you name it ISH. Then of course you have to have the supply plus and minus in the voltage. Then we have I, the total current. Then we have this, the current through the load. So to know the characteristic equation, we know that from the equivalent circuit, it's evident that the current produced by the solar cell is equal to that produced by the current source minus that which flow through the diode and minus that which flow through the shunt resistor. So the total current will be IL, this IL, because it goes up, and here I know the direction of this current goes down. Also, the current of the direction of this current will go down. So it will be IL minus ID minus ISH. And you have to know that the I is the output current, and IL is the photogenerating current here, and you have to know that ID is the diode current, and ISH is the shunt current. Okay. Now we have to remember that from the Shockley diode equation, we know that ID will be I node exponent of the charge voltage and T minus 1. This is according to the Shockley diode equation. And you know that I node, this I node is the reverse saturation current, because now we are working, the diode working on the fourth quadrant, and we know that the N, this N is the diode ideality factor, and we'll consider this at is 1. And the Q is the elementary charge, and the K is the Boltzmann constant, and T is the absolute temperature. And if we are consider the case of open circuit voltage, okay, now we consider the case of the open circuit voltage and short circuit current. Okay, if we have the solar cell equivalent circuit like this, so we have to know that the voltage in terms of the open circuit, so the VOC, we name it as VOC, it will be that N K times T over K ln of the IL over I node plus 1. And the same goes to the current in the open circuit. We name it as like this. Okay, now let's consider the open circuit voltage and short circuit current. If we have this circuit, okay, I just redraw properly to have a new circuit. So if we consider the voltage, we know that when the cell is operated at open circuit, the current is equal to 0, and the voltage across the output terminals is defined as the open circuit voltage, assuming the shunt resistance is high enough to neglect the final term of the characteristic equation. The open circuit then, it will be given that, name it as VOC, it will be approximately equal to the N times K times T over Q ln of IL over I node plus 1. This is the voltage in the open circuit. Similarly, when the cell is operated as short circuit, we know that the V equal to 0. Then we consider the current. So the current I through the terminals is defined as the short circuit current. It can be shown that for the high quality solar cell, the short circuit current is then given that approximately I in the short circuit will be approximately equal to IN. It means that this current it will be approximately the same as IN, which is this current. Okay, now let's see the generations of solar cell. We have first of all the first generation. The first generation is very simple because it's just a single junction. So we have, if we see here, we see the N type, this junction, this up, and we see the P type, only one junction, and it was very simple because it's composed for one junction. We call it the first generation of cells. Then you can see the second generation, what we call the thin film. This one is more complex, a little bit compared to the simple, because you see there is a little bit of heteroduction. It's not only a simple junction. But if we talk about the third generation, it is about multi-junction. You have a multiple of junctions. So here we can have the gallium indium phosphide, and also we can have the gallium indium arsenide. If we see here, there is multi-junction. Here, the role or the main idea of this multi-junction is to increase the efficiency of the solar cell. For up to date, the best multi-junctions that can be give us a high efficiency is the one composed of the gallium arsenide and the gallium indium phosphide and the germanium. If we combine these three junctions, we make a multiple junction of solar cell. With this three junction, we'll have a high efficiency of 44%. We can reach at this rate of 44% of efficiency. So let's see what is the efficiency if we are talking about efficiency. Because if you need to buy a solar cell, you have to know some parameters. So one of the main parameters is the solar cell efficiency. So the solar cell. Okay, now let's talk about the solar cell efficiency. The solar cell efficiency is the ratio of the electrical output of a solar cell to the incident energy in the form of sunlight. This is calculated by dividing a cell power output in watts at its maximum power point, PM, by the input light, which is E, energy, and the surface area of the solar cell. So here, this is the calculation, how we can calculate the solar cell efficiency. Okay, there is some factors that affect the efficiency of the solar cell. What's the factor affecting energy conversion efficiency? First of all, we have the thermodynamic efficiency. What is the thermodynamic efficiency? Photons with an energy below the band gap of the absorber material cannot generate a whole electron pair, and so their energy is not converted to useful output and only generate heat if it's absorbed. The second thing, we have the quantum efficiency. The quantum efficiency refers to the percentage of photons that are converted to electric current when the cell is operated under short circuit conditions. The third factor is the maximum power point. The maximum power point, the point that maximizes the V times I, which is the voltage times the current, which is actually the power. And finally we have the field factor. The field factor is the available power at the maximum power point divided by the open circuit voltage and the short circuit current. Okay, now let's see the main application of the solar cell. Main application. Okay, first of all, we have the water pump. We can use the water cell in water pumping. Also, the main usage of solar cell is on space, on the satellite. We can use also the solar cell on telecom tower to supply the transmitter and the receiver. We can also use it in the houses, solar home systems. We can also use it in the commercial building. We can use also to have a PV, what you call the photovoltaic power plant that can generate more than 100 kilowatts. Okay, let's see now the advantages and disadvantages and application of solar cell. Or we already see the application. So now we're going to see the advantages and disadvantages of the solar cell. The first advantages of solar cell is that it's clean and not polluting as you compare to the other source of energy. And also we have its renewable energy. Solar cells do not produce noise and they are totally silent. They require very little maintenance. They require very little maintenance. They are long-lasting sources for energy which can be used almost anywhere. They have no time life. There are no fuel costs or fuel supply problems. So this is one of the main advantages of solar cell. Let's see about the disadvantages. Because even the disadvantages is very small advantages or is very limited, but still have some disadvantages. First of all, the solar power can be obtained in night time. So you have to have a system that can keep the power, then you can use it later on. This is the first disadvantage. The second one, solar cell or panels are very expensive, of course, because it's require. Okay, the second point that solar cell panels are very expensive because they are costly to make it. So, of course, to sell it will be very expensive. And the third point is the energy has not been stored in batteries. I will tell you because at night there's no sun, so we have to save the energy. So we have to have a system that can can save or store the energy. And the fourth, air pollution and weather can affect the production of electricity. If, for example, it's raining, of course we cannot have the sunlight. Therefore, the solar cell will not function. And the fifth, they need large area of land to produce more efficient power supply. That means we need a very wide land and very large land that is open to the sun. So in order to have a maximum power production. Okay, let's now try to relate whatever we have seen here about the Islamic perspective. We can see the ayah that Allah subhanahu wa ta'ala says, Allah ta'ala, وَكُلُّ شَيْءٍ عِنْدَهُ بِمِقْدَارٍ عَالِمُ الْغَيْبِ وَالشَّهَادَةِ الْكَبِيرِ الْمُتَعَالِ. This ayah is in Surah Al-Ra'd, verse 8 and 9. So, if we try to relate this, we can see in the Venn diagram that Allah subhanahu wa ta'ala say that everything He created with exact limit. So, if we can see in the Venn diagram here, in order the electron to move from the valence band to the conducting band, we have to get a minimum energy. This minimum energy is exact, it's supposed to be 1.1. For example, in terms of silicon, if we see the Venn diagram and the energy level, we see that, let's assume this is for silicon. And silicon, the band gap is about 1.1 electron volt. So in order the electron to go from the valence band to the conducting band, Cb, it has to have a minimum energy of 1.1, more than 1.1 electron volt in order to be released from the valence band to the conducting band. And this is, we can see how Allah subhanahu wa ta'ala says, وَكُلُّ شَيْءٍ عِنْدَهُ بِمِقْدَارٍ. And everything have a certain limit. And the same, if this electron go down from the conducting band to the valence band, the same. it will release the same energy, amount of energy. So, if we see the second ayah, Allah subhanahu wa ta'ala says, وَمِن كُلِّ شَيْءٍ خَلَقْنَا زَوْجَيْنِ لَعَلَّكُمْ تَتَذَكَّرُونَ. This is Surah Al-Dariyat. Allah subhanahu wa ta'ala says, قال الله تعالى وَمِن كُلِّ شَيْءٍ خَلَقْنَا زَوْجَيْنِ لَعَلَّكُمْ تَذَكَّرُونَ. So this one, Allah subhanahu wa ta'ala said we have created everything into two, that means the duality. So if we see in the diode, we have the reverse bias. If you see the function of diode, we have the reverse bias, and you have, this is the positive, this is the voltage, this is the current. So the positive part of the diode, it gives us different characteristics from the reverse bias. This is forward bias, and this is one the reverse bias. So in the forward bias, we'll have different characteristics. The diode will behave in several characteristics, and okay, if we see the functionality of the diode, we can see that we have two modes, either the forward bias and the reverse bias. Of course, we have the first quadrant, second quadrant, fourth quadrant, and third quadrant. Then if we see the forward bias and the reverse bias, the diode have different characteristics, which is the duality. Even in the diode, there is the duality. We see here, in these parts, we have laser. But in the same diode, if it's operates on the third quadrant, we have photodetector. Photodetector. And if we're in the fourth quadrant, and the same thing, we have this, the same thing, but if it's come to the fourth quadrant, you have laser. So this, even in diode, we can say there is this duality of things. These are the forward bias and the reverse bias. They have, in the same diode, you have these two modes, and will give us different characteristics. Finally, we can see the last ayah that Allah subhanahu wa ta'ala says, قال الله تعالى وما أوتيتم من العلم إلا قليلا. Which means that Allah subhanahu wa ta'ala tells us that I only given you a little knowledge. So if we can relate this ayah in terms of this solar cell, every day scientists try to find a very good mixture or a multi-junction that gives us a high efficiency. If we see this gallium arsenide, this junction, and there is a junction of gallium indium phosphide, and we see the junction of germanium. Up to here, scientists, they can find efficiency about 44%. Of course, there is another mixture, but still research going on. So still research going on to discover the best or the more efficient solar cell, which is by using the multi-junction. So we see how our knowledge is limited, and every day we discover many things more and more. So thank you very much. I hope that you enjoyed my presentation. And after this, you see the reference of my work. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.